W also equals Q plus W. What do these two numbers have to add up to?
0.
0. Ooh, fancy. Now, so, what's happening to the volume? Volume getting bigger, volume getting smaller?
Volume's getting bigger.
Volume's getting bigger, so what's the sign of my work?
Negative.
Negative. Oh, now, this is a cool equation, and I will give this to you if you ever need it. So over here on this backside, on the isothermal process, this is how you're going to calculate the work. Why can't we, the reason that we can't use this as a triangle is because of the fact that it's a curved line. So we're finding the area underneath the curved line, which means we have to take the
integral.
The integral. Okay?
Yeah, calculus.
Oh, yeah, calculus.
But this is algebra-based physics.
Calculus board.
Oh, no. This is why I'm giving you the equation. Okay? So this is 0.03, and this is 0.01, right? So here's what we're going to do. We're actually going to go through and we're going to calculate this. So we got work equals. Now, Lenny?
Yeah.
Notice we got some natural log going on here.
Yeah.
Yeah.
Oh yeah.
So I've got N, which is 0.10 moles. And then I've got R, right, which is going to be 8.314 joules per mole Kelvin. And then I've got my temperature now.
1443.
What is it?
1443.
1443 Kelvin.
That's how many joules each mole makes.
Now, I got natural log. Now, what happens when you take the natural log in terms of units, Lenny?
They all disappear.
Ah, they all disappear, okay?
Bye-bye.
You don't have to worry about units when you take the natural log. Now, here's what's important.
Yeah.
On this one,
no unit volume.
volume initial over volume final, okay? So what's my initial volume? My initial volume is 0.01, and my final volume is going to be 0.03. Now, this is where this comes into one big whole idea. Forget everything else. What are you going to be taking the natural log of a number bigger or smaller than 1? Smaller. Natural log. What's the sign of anything when you take the natural log of anything smaller than 1?
Negative.
Negative. Oh, look. What's going to be the sign on my work?
Negative.
Oh, because the volume's getting
Bigger.
Oh, okay.
Ooh. Spicy.
So somebody takes the natural log of 0.01 divided by 0.3, otherwise known as a third. Little mental math there. Still got it.
Negative 1318.
Negative 1318. It's a good year. Okay.
What happened in 1318?
1318.
Of course, you would know.
1318 BC.
Ouch!
Can we get a roast?
It was a good one.
Ouch! That hurt.
What did he say?
He said it was a good year, and I said you would know.
Because I'm immortal.
His
So
gift
forget-
is to teach.
You better watch out, homeboy.
My gallbladder isn't. Gallbladder for a long time. Back up.
It takes 100 years to regrow.
Over Christmas, I plan to grow a new one.
That's his Christmas present.
Okay.
That's his Christmas present to himself.
There you go.
A new gallbladder. All I want for Christmas is a new gallbladder.
A new gallbladder.
Miss me with the 2 front teeth. Just give me a new
Sandra just
gallbladder.
takes out his gallbladder.
So, here's the interesting thing. My work is negative 1318 joules. How much, what's my value of Q got to be then?
1318.
1318. Oh,
It's even better
why?
here.
So here's what's happening in the situation with Lenny. I'm giving Lenny $1,318.
Dang, I don't get to keep any of it.
But he's got to spend all of it.
That's all right.
He doesn't keep any of it.
I'll spend it. How do I?
But you now,
Spend it on
but
something
what do you
that
have to
gets
do
you
with
money.
it? On yourself or make the world a better place?
Dang, I guess go to the world, making the world a better place.
You got to make the world a better place.
Darn.
Okay?
Can you make the world a better place
So,
to make money? at the same
whatever
time?
energy that I put in goes to make the volume bigger. So could I do this situation in a situation where I have a sealed container? And I have an isothermic situation in a sealed container?
No.
No, why?
Because
You can't change the volume. So this only works when you can change the volume of the canister.
Balloon.
Okay? Now, I look at this. My value of work is negative 1318. Hold that thought. Over here, this work over here was what? What was the work over there? Negative 2400. why is this work negative 2400 and this work over here? So going across like this, that work was negative 2400. This work here was negative 1318.
Varies a lot less.
Area's a lot less. Because you could just
It's
look
about
at this
half
and go,
as much.
oh, this area here is smaller than this area work. So if I do an isobaric expansion, that's more work than if I do an isothermal expansion. Ooh.
So complicated.
Now, let's say I bring a line straight down. What's staying the same? This is the easiest. This I'll say this last. That's the easiest.
Volume.
What's happening to the volume?
Nothing.
No. What's happening to the volume? Nothing, right?
Nothing.
Am I doing work?
Yes.
No,
No, no, no, no, no, no, no, no, no,
Why am I
no,
doing
no,
it
no,
there?
no, 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 no,
There's no distance to
Oh,
travel.
there's no change in volume, right? Work equals negative P delta V. Without any change in volume, guess what? There's no area underneath this line. So my work is a big fat
Zero.
Okay? So, if I do no work, right, there's no area to calculate. Now, I'm going, so look at this. I got PV equals nRT, right? I come down like this, what's happening to my pressure? Pressure's becoming smaller, right? But what's happening to my volume?
Stay the same.
Volume's staying the same. Pressure's going down, volume's staying the same. What's happening to the temperature?
Go down.
Go down.
Temperature's going down. I'm dropping the temperature. So when I go down like this, I'm dropping that temperature. True? Oh, I dropped the temperature. What's the sign of delta U? Negative, because I got a negative change in temperature. So therefore, the flow of energy is coming out of the system. So if I'm going to go from a high volume, if I'm going to keep the same volume, and I'm going to decrease the pressure, what do I need to do? Put it in an ice bath or put it in a hot water bath?
Nice.
Put it in an ice bath because I want energy to flow out of the system. Okay?
You and all them Timmy's.
There you go. Okay.
A lot of things. Learn
A lot of things happen.
Learn a lot of stuff.
Yeah. I don't know if I retained it.
Yeah.
But that's
So we
fine.
got the
That's why we have a
video.
video.
Oh, here you go, Jason.
For when you lose this shit.
Probably need the map.
Okay, now, when you get to question number 1,
When you get to it.
so, when you get to question number 1, okay, let me explain that you have uppercase food calories, and this is what's up here. So, it used to be that calories were measured with lowercase c, okay, and like one food calorie was 4.186 joules. But the problem is that when they started doing like the calorie counts on food, they were huge numbers, okay? So literally, if you look at an almond joy, that's what I did when I got this number. An almond joy contains 230 calories. Notice that that's an uppercase C. So basically what they did is that they locked, by going with an uppercase like a kilocalorie and using an uppercase C, they dropped off 3 zeros off the calorie count. So instead of saying, technically, this food is going to contain 230,000 calories by how a definition of a calorie is defined, but everybody would flip out like, oh my God, I can't eat that. That's 230,000 calories. They said, we're just making an uppercase C and drop off 3 zeros. Hey, literally, that's how it happened. Because otherwise, everybody would have been flipped out. So anyway, so we're 25% efficient. There you go, you're on your own.